Hello from Los Angeles. We're looking at a couple of spinners here. This video is actually about this guy right here. This is a new packaging of an older type model I built from a Lidmotor circuit. This one right here is basically using a couple of about 1.25 inch PVC coupling pieces here. And this is an older model of the same thing where I was playing around with it. This one here has nothing to hold the battery in here. Let me see if I can get it open a little bit. You can see how the coil fits onto the little lens or mirror or whatever you want to call that thing there. It's just glued on. And let me see if I can get the circuit thing out of here. It's only using a couple of transistors and a resistor in there. So basically what I've done is, instead of using this larger mirror, I've gone to a smaller mirror to make it look a little bit more compact. And if you notice, the battery in here and the little small circuit and the coil, everything would fit in this area here. But if you have the battery too close to where the magnets are going to be spinning on that little lens, that's the problem. So what I did is I used two of these pieces together of the PVC coupling, and let me stop this a second. And I have a battery holder glued in there. I don't know if you can see it very good. It's a little clip. There we go. So that keeps the battery far enough away from the spinning magnet that it doesn't interfere with it. This is the coil that Lidmotor pointed out to people. Works real good. This is a synchronous motor from a microwave oven. This particular model is the one you want to use. It's 12,000 ohms. When you take this thing apart, you get something that looks like this. Of course, the little contact points are straight when you first get them. And if you'll notice, between the outer plastic and the inside coil, there's a gap. For the model we're talking about, you need to take 10 snips and trim that thing down in size, being careful not to cut the little wire. So you basically trim some of this plastic off. Also, the model here, this particular synchronous motor, the little tabs where you make connections, they bend real easy. If you get these out of a regular microwave, they may be a lot stiffer, and when you bend them back, you may break that little wire. You need to be real careful when you bend them back not to break that tiny wire that connects with it. Also, for the circuit we're using, some of them you get out of regular microwaves are just a couple hundred ohms. Some of them around 3,000 ohms. The 3,000 ohm one will also work. So you need to check the ohmage on the coil if you're going to use a recycled synchronous motor coil out of a old broken microwave. They're in the very bottom of the microwave. They turn the turntable. That's where you can find them. If they're in 3,000 ohm range, or right at 3,000 ohms, they will probably work. And if I use the recycled ones, I just add a coming off the coil an 8 or 10K resistor to take it up closer to 12,000 ohms, not to make the circuit work better, but it saves the battery life. In fact, this particular model will actually run for almost 2 months non-stop. Let me get around to the computer. I've got some pictures here. Okay, here's a Lidmotor circuit. And it's I made a tutorial on Flickr, which I'll put a link in the video to. Obviously in the model there I didn't even use the switch anymore, because with the thing running for almost 2 months non-stop, you don't even need the switch. Or if you wanted to turn it off, you can actually access the battery and just remove the battery. So everything else is the same, I just didn't use the switch in this, so you just bypass the switch. The resistor up there is a 3 megohm resistor. And let me see here. Let me see if I have any more pictures. Okay, this is one where the coil meets the lens. It's not very clear. Another one that's not too clear. Okay, and as you can see on the circuit, I just take a piece of plastic, stiff plastic, and once I've soldered some of those components together, I just glue them on there, and that's my circuit board, if you will. And the bottom part of the PVC, after I've glued the battery clip holder in there, I just run the wires from the battery, the battery clip itself out. So that's the final connection I make when I join the two pieces of PVC. And there's a picture of the battery being held by the battery holder. Another picture there. I think that's about it. So those coils are very useful. This little solar spinner right here, it's using one of those coils. Let me stop this thing a second. This is just two solar panels with that coil in the middle. That's the whole circuit. 2 solar panels and a coil. And of course that's I've made other videos describing how this works. Basically the solar panels are just like you shorten them out, a negative from this one to the positive on this one, the positive on this to the negative on that. Where they meet, you put one wire from the coil to each of those. Solar panels are like this, coil is like that. Works like a champ. There's another one over there. Oh well, hope you're having a good day. We'll watch that thing spin a little bit. Have a nice day.